Hi everyone. In this session, I am going to show you how to extract text from an audio, not just only text, but along with the speaker labels. Let's say you have an recorded audio with you, and there are two speakers involved over there. Now you want to extract text out of it along with speaker labels. What is that speaker one has said? What is that speaker two has said? Right? So the better example would be like a politician giving an interview to a journalist. So journalist has asked some questions and the politician has replied some answers. So you want to have this entire conversation in a text format rather than listening to their audio clip. You just want to have a text file for this. So I'm going to show you today how to do that actually. But before I go there, I would like to show you what is this user case like. I mean, this entire text to audio to text or speech to text file has multiple what to say branches over here, but I would like to show you. Let's please check. Let us say you have an audio file, right? If you can see my screen, if you have an audio file, right? It could be a live one, or a recorded one. So let us say you have a recorded audio file and this is a live one. Like, okay, in the recorded audio file, again you have two branches, right? One is you have only one speaker and you have more than one speaker, right? If you have one speaker, you don't have to watch this video. I already made one more video which is already in this channel. I already showed you how to just extract the entire text of an audio clip with just 3 lines of code, right? Just 3 lines of code. I already shown you one video. Please go and watch that channel. Now, if you have more than one speaker, again there are two combinations over here, right? One is if your model. Let's talk about the second one first, right? If your model does not get trained with the voice of the speakers. So let us say I did not train my model with my voice. So then obviously my model don't know Raghav is speaking over here. Let us say I am speaking with my friend Pooja over there, and Pooja voice model did not get a chance to get trained. So it will not identify it's Pooja voice, it's a Raghav voice, right? So it will not able to identify. In that case, we use a technical instead of getting the names, we use called speaker one or speaker two or speaker A or speaker B, X comma Y, something like that. So in those cases, we call it as speaker labeling. Basically, we are doing speaker labeling over here. This is nowadays being called as speaker diarization. This concept is also called as speaker diarization, right? Okay, let's talk about this model. Here we have the trained records, sampled voice records of the speakers. That is a Raghav sample. Raghav you have a Raghav audio file you have, right? Whatever Raghav spoke, you had an audio and you trained your model. And the speaker to whatever Pooja has spoken, you have our audio. So when you train the model and when you give it, and the text comes, you will get Raghav said has said this, Pooja has said this, like this you'll get. So in this video, I am going to show you this scenario, speaker labeling and speaker diarization. This is the thing I am going to show you in this audio. And guys, if you are already working data scientist or a machine learning professional, you need not watch this entire video. You can just go and run the code and you can do it. But if you are a new to text analytics or NLP or advanced text analytics, and you would like to have the entire background very clearly, then please watch the entire video. Okay, guys. So today we are going to discuss about this one, right? Okay, let's go and get into coding. So transcript with speaker names. Actually, it's not speaker names. It's actually speaker labels. Actually, okay. Okay, I could not rename it for some time, but it's actually speaker labels actually. So this entire code is contributed in the open source by a person called Mr. Dwarkesh Patel. He is the one who has actually contributed this code in the open source. All credit goes to him. I'm just showing you how to run this code and get an understanding of this one. So yeah, let's jump to the code. So this is the Google Colab working environment. So I'll paste this link in the description. You can just click on it, come over here. Yeah, once you come over here, you have to click on the runtime. Okay, go to the bottom and change runtime type. So last but fourth option is change runtime type. Just change it to the GPU. Make sure that you have GPU over here, right? And click on save. Okay. Now I would like to text an audio file. So I went to this website called www.moviesonclips.net and I went to, I selected some movie. I tried to download this audio, right? This is the audio I would like to test now actually. So there is one audio between Bruce Wayne and Henry Duggart. If you see this conversation, So this audio has this conversation actually. If you click on it over here, you can listen to it. So are you so desperate to fight criminals that you lock yourself in to take them on one at a time? So the Batman has said, actually, there was seven of them. Then Duckard says, I counted six, Mr. Wayne, right? So this is the conversation. Now I would like to extract text out of this audio file. I have downloaded this audio file. Just click on this MP3 and download the audio file. Keep it ready in your local machine. Now come back again to the script and come here and run this. This is called Google Collab environment. For those of you who don't know, this is Google Collab environment. This is just like a Jupyter notebook or VS Code installed on your PC, but it is running in the Google Cloud. You just need to have a Google account. If you do not have a Google account, please create a Google account and then log in over here. And this is called a cell. If you click on this play button, the cells get executed. The entire code is being written in Python 3 language, right? Just click on this play button. Okay, yeah, that's fine. Run anyway. So now what you do is that you select the file, whatever the file you got, like downloads and criminals. Yeah, I'm downloading this file and uploading it over here, right? Once you do that, now the file got uploaded. Now you need to specify. If you remember, I was saying you in the whiteboard, like if you have more than one speaker. Okay, this is scenario we're talking about. So now we have to specify how many number of speakers are there in the audio. So if you come here, we're just specifying number of speakers as two over here. If you can see my screen, if you can see my cursor, so number of speakers I'm specifying to, and the language is English in the audio clip, whatever the language you have in the audio clip. So we are doing everything using this library called Whisper actually, Whisper library. Whisper library has around five versions actually. A model, so model has five versions. One is tiny, another one is base, three is small, fourth is medium, fifth is large. These are various size of the model. Okay, right? So what happens over here is that if you select the large model, your accuracy would be higher, but your processing time also would be higher. If you select the lowest one, your accuracy would be lower and your time also would be lower. It's a trade-off between the time and accuracy. Based on your user case, you can decide which model you want to select, right? So in this case, I am selecting the medium model, right? I'll just select a medium model over here, right? And then execute this cell. Okay. So in this cell, what is happening here is that we're downloading a Whisper library and we're importing some libraries over here. Yeah. If you see over here, you might get a question. If you're a beginner, at least you will get definitely a question. I did not train my model with the speaker voices. Okay, then how is that model is recognizing that this voice belongs to this speaker one, this voice belongs to speaker two? How is it recognizing? So if you can go to your fundamentals, let's say for any model to predict, it should get trained. But we are not nowhere training this model with the Bruce Wayne voice or the other speaker voice, the Batman voice or other speaker voice. But still model is able to differentiate who is speaking. It may not give the names of the persons, but it is able to say this speaker one voice, speaker two voice. This is very simple, guys. So we use a technique called clustering. Okay, right? Let me show you. I will give you 1 minute intro about what is clustering. What is clustering? Clustering is very simple, guys. So you have a unlabeled data set. So in the audio recording, you have both speaker one, the Batman speaking, and the other person speaking. Like you have both the text. They're unlabeled. Who is who? We do not know within the data set. The algorithm does not know. So I mean the model does not know this one. So what clustering technique is that it will try to plot them in a graph. Okay, assume this is a graph. This is the x-axis. This is the y-axis. Now let's say it will plot everything basically. It will plot both their voices. And let's say that the graph looks like this and like this. The graph is now looking like this. Now in clustering, what happens is that it will try to group similar elements. Okay. And if you see all these red points are together, right? And all these black points are together, right? Okay. So this is called cluster one. This is called cluster two. Nothing but this is not clustering, nothing but grouping, boys. It's nothing but grouping. Simply it is called grouping. You have an unlabeled data set, and based on the similarity, you decide into two groups, right? In this case, group one, let us say, and group two you have. Okay, group one is nothing but Batman and Batman are so Batman, and the other person is called speaker 2. Someone else is their name. I don't Henry Duckert, some name is there. Okay, so this is right. So it's nothing but simple. So algorithm try to plot it on a graph, and we'll try to group the points based on similarities. If you see, all the red points are, one red point should be very similar to the other red points, and these red points should be very dissimilar to the all these black points. Within the cluster they should be the same, there should be a resemblance, but one cluster to another cluster there should be a difference. This is just clustering technique, guys. Based on this only our entire algorithm model is running. So there are a couple of ways of techniques of doing clustering. One is k-means, and another one is db scan, another one is hierarchical. Under a hierarchical, again you have, agglomerative and divisive, right? Okay, so in this use case we are using the agglomerative clustering actually on here. So if you can go to the model over here, yeah, if you go here, we are using from sklearn cluster, we are using agglomerative clustering, right? So yeah, lot of nano over here. So so what is happening in this cell is that if the model is designed to accept only WAV file formats. If you give any other file format like MP3 and all, it will get converted into WAV format. That is what happening over here, right? So then we are loading the model here. We have selected the media model. So media model we're getting loaded over here. Model is equal to whisper dot model load model. The model size we have given on the top as medium. So it's around 1.42 GB. It is everything it is doing in the cloud, guys. It is not installing anything or importing anything to your laptop, right? Okay, the model is getting loaded. Now, yeah, we are just saving it in this result, and we're just segmenting result dot segments, results of segments. Yeah. So it is rotating, that means the cell is getting executed. It's when it comes green tick, that means cell got executed within so many seconds. And we are doing some embedding over here. And he was saying that the author was saying that whisper overshoots the end timestamp in the last segment. So in the last segment, when whisper is overshooting it seems. So be careful with this thing. And we are using some embedding techniques over here. And in the end, we are doing agglomerative clustering. Whatever the clustering we called over here, and number of speakers, and we're embedding over here. Then yeah, here we are opening a file called transcript.txt, and we are writing into the file, and we have closed the file. Now to see our final output, just come to the left and click on this file, right? Click on this file, right? You see transcript.txt, right? I uploaded only, criminals.mp3. So that is converted into, since it is an MP3 format, the model has converted into WAV file, audio.wav file. From that audio.wav file, you got transcript.txt. Just click on the three dots and click on download, right? Okay. So now see, this is the text it is recognizing. Speaker 2 was saying, "Are you so desperate to fight criminals?" This is the first sentence as it is. And in the second thing, actually there was 7 of them. Okay, but speaker 2 has again this gave reasonably right, but last sentence was actually being spoken by the speaker 1. If you go to this file, this last sentence was spoken by the another person. Maybe this is what he is saying. The author was saying in the last segment it is overshooting. Maybe this is what the author was saying, that thing. But apart from this, I see it is a good result over there. Please try with some other models. Please try with some other different kind of models, or use some other techniques, and let me know if you get any better feedback, so that I'll make another video out of it. And yeah, I would like to show one more thing. And he has even deployed it in the Hugging Face. You can just specify number of speakers over here and upload your audio, and click on submit. Then it will keep on loading like this, and at the end of the day we get result over there. The same thing I have shown you the entire coding part also. Thank you, guys. Thanks a lot for patiently listening to me. And I will paste all those links in the bottom.